Hello, and thank you for joining us. We are Group 21, and my name is Zachary Mosley. We're joined by Levi Strawn and William Millar to present our design for the band-in-a-box problem. Today we'll discuss our solution to maroon and gold forest problem to create a set of instruments capable of playing one of their hit songs that can all fit together inside of a 2-foot box. Meanwhile, each instrument must be less than $15. And finally, we must have one wind instrument, one string instrument, and one percussion instrument. We'll start with a wind instrument. On slide 2, you'll see the design for our wind instrument. It's based off of a pan flute and features 9 half-inch PVC pipes cut to the appropriate lengths to play the high notes of alma mater. PVC is cheap and readily available material and very easy to work with. The clay stops in the bottom of the pipe allow for easy tuning, and additional pipes to play more notes would be quite trivial. Duct tape helps protect the clay stops from being damaged, and the pipes were originally designed with 1-inch pipes. While these did produce the correct frequencies, the amount of air that had to be blown through the tube proved to be quite difficult to produce, so I switched the design to half-inch pipes. This also helped reduce the width of the instrument while slightly increasing the length. You could improve the design by using a different material, such as bamboo or copper or brass. Another way to improve the design aesthetically would be maybe like a woven wrap to secure the tubes together, or a different way to protect the clay. The duct tape's not quite so pretty. On slide 4, you'll see the calculations and equations used to determine the lengths of the pipes. The pipes produce sound by having air blown into them, hitting the bottom of the pipe, and then traveling back up, creating a standing wave as it reverberates on itself, with an antinode just outside of the pipe. That's where the sound is produced. I learned a lot about the acoustics of how music works constructing this instrument. Although I did not run into any major challenges, I do wish I could have moved into the testing phase a little bit earlier to get the instrument finalized. And I'll go ahead and pass this on to Levi.
Hi, I'm Levi Strawn. I'm here to introduce to you the stringed instrument for the band-in-a-box project. This is a solid Douglas fir construction for the beam. It's got a large resonance chamber that's easily removed for storage or to change the strings out, because the strings come through the body and out for improved sustain of notes. Up here we have machine tuners that will hold your strings tension once you reach the desired tension. There's 7 notes per string, and that's enough to do all of the mid parts for the song Alma Mater. Sound quality is good, I think. Had a lot of fun working on this project. I wanted to build something that was on the large end of the scale that would still fit within the 2-foot cube box that was required of the project, that utilized the maximum amount of the strings length that we had, which is 4 foot total. If you look at slide 5, you will see pictures of the design. If you look on slide 6, you will see the physics behind my design. And I'm going to hand it off to William Millar for the next section.
Hi, my name is William Millar, and I'd like to present to you my wooden bar xylophone design. This design features 9 wooden bars suspended in a simply supported format. I'd like to play quickly a few notes for you. So the physics behind this, I used the equation length equals square root of pi times 3.00112 squared times 4,283 times 0.001835 divided by 8 times the low frequency values. Then I took the length times 0.224 and times 0.776 for each bar to get the location of the nodes. The results of this are located on slide 10. So my design changed a few times throughout the process. I started off with a steel cantilevered bar design, and I tested it, and it sounded not really, it wasn't good, so I switched to a simply supported design and redid my calculations. I found that a wood would be a better choice for this design, so I went with poplar, which is quite inexpensive. The materials list is located on slide number 12. The total came out to $14.33. Overall, some of the challenges were getting the notes down to a low frequency while maintaining a low size. To improve my design, I would have went with a wood with a much lower velocity of sound, or also a thinner bar, both of which would produce lower frequencies. So overall, our group as a whole reached most of our goals in this project. Each instrument fits nicely inside of the box together, and they all produce high quality tones. Each instrument also costed less than $15 to produce. If you'd like, check out our song and let us know what you think. Thank you.